Our next speaker, this is a keynote speaker, Edward Sharp. Up until recently, he was the CTO and Chief Strategy Officer at PMC-Sierra. Obviously one of the major storage semiconductor companies around. PMC-Sierra is in the process, I think it's actually closed now. It was bought by Microsemi. And Edward's not going to move forward into Microsemi, and so he's still giving us our keynote. Of course, he's a very bright guy and a very good brain. It's very obvious to me that as this whole for persistent memory happens, or storage class memory, as some companies call it, Microsoft I think calls it storage class memory, some call it persistent memory. There are lots of applications. Obviously the cloud providers are able to do the whole vertical stack by their own. HPC is probably pretty similar. There's key applications like databases in general, in-memory databases that could, really own the whole stack, could move very, very quickly on it. But I expect that there's going to be a very, very fertile ground for startups in this space. That, startups that will really fuel the deployment of persistent memory and its advantages to the masses of data centers and masses of applications. I think it's very easy to predict that that's going to happen. And I'll further go forward and say that I think that Ed Sharp is going to be the CEO of one of those TBD startups. Who knows? That's Jim's prediction here of the future of Edward Sharp. So anyway, with that.
Thanks, Jim. We've made tremendous progress as an industry. In the media, in the controllers, in the networking, CPU, into the OS. We've made all this progress on non-volatile memory. And the question I have for us here is that sufficient to tap into the opportunity? And if we think about the opportunity as the amount of stuff we store every year, and visualize that as the volume of the Earth. That's how much HDDs are shipped every year. 500 exabytes or so. How are we doing in non-volatile memory? For NAND, we're doing pretty well with the volume of Mars, about 1/10 the volume of the Earth. Pretty good progress, room to grow. But how about other stuff? DRAM, which I know is not non-volatile, about the volume of the moon, about 1/10 of that again. If we look into storage class memory, next generation NVM, doesn't even register. An asteroid that's kind of interesting when it explodes, but irrelevant to the greater society. And so our opportunity is, how do we go find these applications? How do we go find these workloads to tap in to the hundreds of exabytes going to zettabytes of data that's being stored and transacted on? And let me just introduce a simple categorization that I have of DRAM-like memory, which is fast but expensive, byte addressable memory interface, replaces maybe a supercap with DRAM today. Storage class memory, which has many of the characteristics, but it's a lot cheaper than DRAM. And then, of course, NAND, which is doing well. And let's put numbers on those. As I mentioned, HDDs at 500 exabytes going to 2,000 exabytes in 5 years. But if you look at NAND, NAND has gone from less than 100 exabytes to more than 300 exabytes over the next 5 years, and DRAM going from less than 10 exabytes to more than 20 exabytes over the next few years. The question on my mind is, what's going to happen to this storage class memory? Is that going to become hundreds of exabytes, or is it just going to be a niche thing that, interesting for some workloads, but not changing the industry? And what do we need to do to tap into that opportunity and make storage class memory a big piece of that pie? And the reason people would do that is, of course, because of latency and the economics. And this is another version of a slide that's been showed 5 times today. We are interested in the latency benefits that non-volatile memory brings, which is order of magnitude better than drives and even NAND. And as we've seen earlier, with more sophistication, more data, is that there's overhead elsewhere in the stack that is coming that is coming to the forefront when you go to these faster memory types. And I'll come back to that, particularly on the software side, a little later. But to give a summary of where we are, we see orders of magnitudes in improvement in latency as you go from HDDs up to DRAM drop-in, and orders of magnitudes improvement in IOPS as you go from HDDs up to DRAM drop-in, and orders of magnitude improvement in bandwidth. Of course, economics is the other side of it. But it's not just changing the media type that will unlock the benefit. And this is, down the left-hand side, what's happening to the media. So let's see what's happened elsewhere. And what have we collectively, as an industry, been innovating on? And should take a moment to celebrate and to congratulate ourselves on the innovation on the media, in the controllers, in the networking, in the CPU infrastructure, and in the software and the OSes. And let me give you some examples and give people a chance to pat themselves on the back. On the media side, some examples of DIMM form factors, where a number of vendors have been pushing the envelope and delivering great value to the industry. Of course, they have their issues, whether it's on price or performance. But picking on a slide we saw earlier, the Intel Optane stuff. Yeah, it's absolutely going to be faster than NAND and denser than DRAM. Intel can tell us it's going to be cheaper, but we haven't seen a price yet. And until there's real competition, I don't know if it's really going to be cheaper. So that's going to be one to watch. But this innovation is critical. You've got to deliver the media that's going to unlock the latency benefit. But it's not sufficient. And so my, as of today, ex-employer has done great things on the controller side with the Flash Tech controller for non-volatile memory that can handle the capacity, the performance, the density, and the programmability that we need for this new world of non-volatile memory. Million IOPS, huge capacity, innovation on the error correction dimension, software programmable, great innovation that's helping unlock the potential of non-volatile memory. And if we combine that into a card, and this is PMC/Microsemi's Mount Ramon card, which is a proxy for an SSD with next generation non-volatile memory. It actually happens to be DRAM with a supercap and the Flash Tech controller. And look at the performance profile it delivers. Less than 10 microseconds with a very tight distribution. So low latency and great QoS. This is the innovation that this industry has been delivering to unlock the potential. And we got to keep doing it. And we've done great jobs on the networking and the protocols. And this organization that we're all participating in today, instrumental in NVM Express, and what that does, not just for bandwidth, order of magnitude better bandwidth, but also on latency. Without this, we wouldn't be able to unlock the potential of NVM. And that's not just in a siloed environment, in a shared environment. This is the SwissTech product as an example from Microsemi, which enables you to share and scale the use of NVM. It's critical for people to take advantage of it, drive the economics and drive the performance. Although this is limited in a rack. So how about if we go beyond the rack? Well, you know what? As an industry, we're solving that as well. With a lot of work done on RDMA and getting the latency down to sub 10 microseconds so that you can access this lightning fast non-volatile memory in a distributed environment. All critical innovation for us to unlock the potential of NVM. On the OS side, the OS is interesting to watch because with Linux being open, you can see what's happening, and you can see the effort going into NVM Express, into persistent memory support, into memory mappable, heterogeneous memory types. This is all coming together. And as summary, I think the industry's done a great job on these dimensions, pushing the envelope across the board to unlock the potential of NVM. And we keep doing it. The storage class memory that a lot of people referred to today, we see a lot of innovation going on in the media type. We see a lot of innovation going on in the controllers, in the networking, in the architectures, and in the OS. But who cares? All of this is exciting for us. But in my scientific study of the world, we've got a perfect distribution. And most people don't care. Of course, we all care deeply, right? But we're on the tail of the tail. And the challenge is that is what people have today good enough? And I would say that the people that care ultimately are the applications. All of this work we do is for the applications. And so we have to think more about what those applications are, how we can tap into them, how we can expose our value to them, how we can get the application folks using the innovation that this industry is bringing to bear. And turn the stack upside down of media controllers, networking, and OS, and put the applications at the top. And the applications is all around serving a business goal. And they just want it fast enough. They're coming from a world in which HDDs were state of the art. And we heard earlier today, the latency of HDDs is like in outer space. And we deliver stuff that's down here. Well, how do we get the applications to take advantage of it? Or in another analogy we heard, your heartbeat is what it takes to get a piece of data from memory. And you got to walk to Miami and back to get it from an HDD. Those applications, they're not ready for the heartbeat. You take OLTP, for a long time, the benchmark of needing performance storage. Well, now you give them 5 SSDs and they're screaming. They don't need any storage. They don't need any more. Maybe give some in-memory database to HANA. Our application's going to tap into everything we're doing. You know, these are the big applications that people are using today. This is what's driving the tens of billions of dollars in spend on software and infrastructure. So fortunately, there are new applications coming along. But think about what it took, how long it took, and how people are using the last disruptive non-volatile memory, Flash. You know, Flash has been around for a long time. And it was used as a cache. Critically, no software changes. Huge performance gains from a little bit of Flash. Took a decade to get to the mainstream. And you have some talking today about, well, you know what? I got another no software change, and that's using NVM for capacity. But that's going to be a NAND game. This new stuff we're talking about, that's not the capacity game. Well, NAND is going to hit a wall sometime, but 3D NAND gives it a long life. And it's niche today. Maybe it will become mainstream, but you know, Seagate and Western Digital aren't going to stand still. Non-volatile memory as memory requires software changes. And it's going to be workload specific. And it's going to be niche initially. And with our collective efforts, we can accelerate the time it takes to get that to mainstream. We can accelerate the time it takes to tap into that volume of the earth storage on non-volatile memory. So as an example of an old application benefiting from non-volatile memory, this is OLTP database, NAND uses disk. And the cost of this over 3 years, comparing disk, an all-flash array, and a tiered system. And that big bar at the bottom is the database licensing and maintenance. So it's the software costs. How do these people tap into the cost benefit of NAND? They get rid of software because they don't need huge systems. They can do it on a smaller system. It's certainly useful and interesting, but it's not going to drive exabytes of demand for memory technology. So we got to go beyond just accelerating legacy applications. And I asked the question, what needs more performance than NAND? Because NAND is orders of magnitude faster than HDDs, this case SMR, shingle magnetic resonance drives. And it's pretty close in cost, whereas other non-volatile memory, more expensive. The fortunate thing is we have those new applications. They're the big data applications. And we've got to go tap into those. There's also changing in the storage frame, the storage landscape, but I think the big data applications are the ones that are going to be the opportunity for us. And as an example, this is an Aerospike non-SQL database using NAND as memory rather than NAND as disk. And the big change that this non-volatile memory, fast non-volatile memory does for this application is deliver so much more capacity per server vis-a-vis DRAM for the cost and also the scalability. And because you've got a lot more capacity per server, although the cost per server is roughly the same, the numbers of servers is dramatically different. And so the total cost of this solution is dramatically different in the non-volatile memory world versus using DRAM and disks. So to do this, we need to go connect with those real-time applications. what are those applications that are going to go drive the demand for the innovation each and every one of us are delivering? Real time creates tremendous demand for low latency and deterministic latency. So we have to engage with the software ecosystem. We have to add software ecosystem to this stack of innovating on the media and innovating on the controllers and innovating in the networks and in the CPU and in the OS. We have to get into the application. So my call to action to you is to go find those applications and engage with them and get them to be using your innovations. We can also look for opportunities where the price performance gain changes because of the innovation we deliver. And let's make sure we take advantage of the innovation that we deliver. Make it flexible, make it software defined. The world will be changing. And learn what's coming. And the best way I see to learn what's coming in this world is to look at the OS. You know, Linux is open, you can see what's changing, you can see where people are innovating. Looking at what's happening in Linux tells us what's coming. So if you remember nothing else from today, remember that the application is the king of the hill, and what we are doing needs to be linked to unlocking the value in the application. Thank you.
We have time for a few questions.
Yeah, go ahead.
Could you elaborate a little bit? What do you mean by software-defined?
What is meant by software-defined? NVM. Software-defined. If we step back and think of software-defined and throw out the marketing and everyone is moving towards it, momentum, and say that ultimately software-defined for me is around indirect addressing. It is around virtualization. It is around how you can use a hardwired piece of hardware in a flexible, evolving way. And so the Flash Tech controller, for example, from Microsemi, has software defined in that you can move some of the error correction into the application or OS. So how you use an SSD with that controller could be different than somehow other application uses it. And my belief, if you look at what virtualization, what indirect addressing has done for computing, is that up and down the stack, the more we can make the solution flexible with software and allow that software to link with a use case differently, the better off we will be. So in the specific case of software-defined NVM, the example would be the Flash Tech controller, where that software parts of that software can be done on in the application or in the OS. For the benefit of cost, performance, capacity. But I'm sure there are applications in other areas of the stack. Yeah.
I think your argument was that one of the things that will help reduce overall costs or improve economics is that you'll need fewer servers, and therefore you'll have to pay fewer expensive software licenses for all that database and middleware software. But the guys who make that software are no dummies, and won't they try to raise the prices as they see their unit volumes decrease and wipe that out?
Yeah. The question is, given that a lot of the benefit we've seen from, for example, NAND going into servers is that instead of 50 servers, you can get by with 10. so you don't only buy 10 licenses of Oracle database, won't Oracle say, oh, well, hold on, I'm just going to put up the price 5 times because I'm serving an ultimate workload? And that is one of the challenges in a traditional world in which NAND comes in and just replaces slow disk or other non-volatile memory comes in and replaces the slower media that you don't need the capacity for. And that is why I'm saying we've got to go and find these new applications and drive the demand for the new applications. Because whether Oracle puts up the price or not, selling 5 terabytes of flash or storage class memory is not that interesting. When I joined NetApp in 1998, we sold a 1 terabyte storage system for $1 million. 1 terabyte, $1 million. Databases are bigger than they were back then, but they're not 6 orders of magnitude bigger. Right? And so if we stuck with those applications, our market would get smaller. We've got to go find the new applications. Other questions? Thank you.
Thank you, Edward. I think was it last year you became the CTO at PMC, I think it was, right? And we met for the first time, I think, across the hall at El Forneo. We had dinner or lunch together. And since then, we've become, good professional friends here. And this was actually the first time I've heard him speak, and you did not fail to impress. So you did a great job. Thank you. So I'm going to hold by my prediction about one of these startups you're going to be running up. Our next speaker, our next 2 speakers, Jeanette and John Chen from Trendfocus, are coming up, and they're also repeat speakers at this event and always do a great job. So I'd like to invite them up and go through actually, they're going to be talking about the exciting things that are happening in solid state storage.
Is it already on there?
Is what? Oh.
So while Jim's figuring that out, it's great to be back. Good to see old friends and new, some new faces. Always a pleasure to come to the SNE event. Again, John Chen and I work for Trendfocus, small analyst firm, NAND, SSDs, hard drive, market analysis. We've been in business for about 24 years now, so quite a few years. We're not newbies on the block. We're going to focus on SSDs. Obviously touch on some interfaces, some NAND metrics, and we've heard a lot today about a lot of specifications and how certain things are taken, poised to take over the world. We always hear about one spec wins over the next. We might take a little different angle, talk about some supply questions the industry needs to ask, some other business metrics. Obviously, we're going to touch on the magical pricing topic and give it that angle. So again, at the end, throw darts at our assumptions, ask any questions you like, and we'll go from there.
And I think we need a copy of the presentation.
I think we're missing a copy of your presentation here.
Yeah, that's sick.
I sent Jim Ryan. You have it? Comes prepared.
Eagle Scout.
There you go.
NAND Flash saves us again. Now go.
There you go. See?
That's right.
We had it on a floppy, but we didn't think they had a floppy drive here, so.
And just a little bit about our backgrounds. I think we're pretty well rounded up here. I have a very smart engineer to my left, John Chen. I'll let him talk in a second. But myself, started out at Fujitsu, doing product management, product marketing for hard drives. Marvell, probably got some Marvell coworkers in the audience. And then Toshiba, where I was in the marketing organization, both for hard drives and SSDs. SSDs since about 2008, plus or minus. And then I'll let John.
Hey, Jim, hey, try, you can just download the PDF and run from that if you can't find your. It's already posted.
Okay. All right.
Who's there?
Nan's not doing the job here.
Maybe it's the USB interface.
It could be USB. Find the guy who invented that and kill him. For those of you who don't know, that was my first job at Intel was as Mr. USB. So, of course, Nathan doesn't forget. There seems to be a few other missing ones in there as well. What's that? Oh, there we are. Yeah. Were we not looking at the right directory or something?
Okay, we found it. Okay. Okay, we got it.
All right. So before we begin, I'm going to just stand here and let Don pace around, because Don's known for pacing around the office. We are in a little tiny office with 5 guys, and he's the most mobile of the 5 of us. So he gets the mobile mic, and I'll stand here and throw in some color as we go.
Sounds good. Okay, so let's talk about NAND for a minute. All right, so these are Q3 actuals that give us a baseline of where we are as an industry. We did about 22 exabytes that one quarter. We did about 84 exabytes for the year, 84 to 85 exabytes. Hard drive industry did about 500 exabytes for the year. So that tells you the discrepancy there between the two. We look at the supplier base, right? Five suppliers that rule the NAND world. Pretty nice splits on the shares there. You guys are familiar, you probably work at some of them, or familiar with who's ahead on certain technologies and leading the charge there. If we look at NAND type, we did have a big shift from MLC to TLC mid last year, so it's about a 50-50 split now there. TLC in SSDs, though, is still a low percentage versus all other planar NAND technologies currently shipping in SSDs. That's NAND technology going into every application that you see in the bottom pie chart. Right? So SLCs, or MLC is still the dominant NAND technology in all SSDs in the world. We'll talk SSDs later, obviously. If we look at where all the NAND is going, you see SSDs. It's about a third of the market. A year ago, it was 29% of the NAND output. In Q3, it was about 35, 36%. So it's growing steadily. We're averaging about 15% CAGR unit growth. SSDs, we're averaging a 30+% bit growth at NAND. Okay? But that means almost 2/3 of the NAND has to go somewhere else. Your phones, your tablets, embedded, other stuff, right? So there is a lot of NAND out there, relatively speaking, but only a third of it goes to SSDs. So when we talk about enough NAND supply and SSDs taking over the world and taking over those 500 exabytes of shipping in hard drives, we have to think about that, okay? So I'm going to talk unit base, then I'm going to talk capacity base. Okay, so if we look at the SSD industry, right, I have a good chunk of the major players, or a lot of the major players up here. You see how many units we shipped in Q3, about 26 million. You see the split between enterprise and mobile. Right, all your client SSDs for your notebook systems on the left at 23 million. We did just over 3 million enterprise. Okay, we do about 60-something million enterprise hard drives a quarter. Okay, we do how many notebooks?
16. What?
How many client drives?
Well, we do about total on the performance side. We do, and nearline side, we do about 16 million units on enterprise, and then the balance of it is client and consumer electronics.
And on the client side, we do about 170 million notebooks a year. We did 23 million SSDs that quarter. A lot of those are aftermarket there, but you see the dominant players there. So, and you see a lot of the same color in a lot of these charts, right? So it gets interesting when we talk about pricing later on. Remember those names and who has a large piece of those pies up there. Let's talk capacity shipped, bits shipped. Client, we did about 5 billion gigabytes, okay? Of those 22 billion gigabytes of all NAND shipped, 5 billion went into client SSDs. There's one dominant player. It's going to remain nameless, but you can take a guess who that is up there. Enterprise, we did just over 2 billion gigabytes, right? Again, you see a couple dominant players up there. So now let's think of NAND technology, capacity points, and pricing. If we want to change, interfaces in either one of these segments, right? Obviously, SATA is still a dominant interface in most of client. We did about 19 million last year total. We did about 19 million PCIe client SSDs for notebooks. Over 18 million of those were one company, and you guys can probably take a guess who that is. So we did less than 1 million PCIe SSDs for the rest of the world for all other companies, right? On the enterprise side, of all those units and the 2 billion gigabytes shipped, we did about 2.5 million SATA. We did 450,000 SAS, and we did 117,000 PCIe. So Jim's here. Is Jim still in the room? Jim, we cracked 100,000 units of PCIe in the industry. I was here a year ago. I was hopeful we'd crack 100,000 in one quarter. We finally did it. Okay, so congratulations there. So if any one of those companies are going to drive a transition, say to SATA to PCIe, you got to think about your current customer base. How are you pricing your SATA solutions if you're offering both?